All right, here we go with exponential and logarithmic equations. Exponential, logarithmic equations. The basis for what we're doing today is this. If you have an equation where you have the same base on both sides and the bases are the same, that means the only way they can be equal is if the exponents are the same. So that's what we're going to do. We're going to get the bases the same on each side and then set the exponents equal. Here's the first one. 4 to the x plus 2 equals 16 to the x minus 3. Now what I'm going to do is I'm going to make the bases become the same. So this side has a 4. It's always in your best interest to make the bigger one become the smaller one. So I'm going to take the 16 and make it become 4 squared. Still have the x minus 3 over here. And I'm going to go from there. This side's still 4 to the x plus 2. Over here, remember when you raise one exponent to another one, you multiply the exponents together, so I get 2x minus 3. And now if you look, both bases are the same. They're already equal, so don't have to worry about those anymore. Just set the exponents equal to each other, like this. Move the x over, move the 3 over, and you get x is 5. And if you were to plug that answer in right there, it would work, and that equation, it would solve it. So basically, take the bigger one, try to make it the smaller, or sometimes you may have to reduce both of them. And then once you get the bases the same, set the exponents equal to each other, and you're good to go. Next one, you may have a fraction one like this. So you can do negative exponents if you want to and flip them, make them not fractions anymore, but I think y'all are good enough not to worry about doing that. I'm going to keep the 1/3 like it is, 1/3 to the n power. I'm going to change 1 over 81 to 1/3 to the 4th power, but that's also raised to the 2/3 power. So what I have now is I have 1/3 to the n power, and over here I have 1/3. Remember, you multiply your exponents here. 4 times 2/3 is 8/3. Because your bases are the same, just set your exponents equal, and n is 8/3. So not bad at all. Again, one more time. Get the bases the same. You can drop the bases in and just set your exponents equal and solve. Now we got some log equations. So I'll show you what we're going to do here. First of all, in this first one, divide both sides by 2. Make that 9. And then because I just have one log, you got to do the log. Remember, do the finger thing. So I'm going to say that base, because it's ln, is base e. So x would equal e to the 9th. And I don't have my calculator with me. It said rounds to nearest hundredth. To do that, I would just punch in my calculator e to the 9th power and kind of go from there. The second one, I'm going to start off by, you always want to, if you just have one log, you want to isolate it all the time. So I'm going to, first of all, move that 7 to the other side. Make that become 6. Divide by -3. So I have this right here. I have -2. Now I'm going to do the finger thing because I have one log on that side. So the base, since this log is base 10, so I'm going to get 10 to the -2 power is 10x. 10 to the -2 is 1/100th. And if you divide 1/100th by 10, you're going to get 1 over 1,000. And that's your answer there. And the last one here. Same deal. The log is already on a side by itself. So what I'm going to do is I'm going to do the log, do the finger thing. I would get 5 to the 20th equals x to the 4th. And to solve, I would do the 4th root of each side. Now the 4th root is the same thing as doing the 1/4 power. So if I do 5 to the 20th to the 1/4 power, you're really taking 1/4 of 20, which is 5. And everybody knows 5 to the 5th power is 3,125. And that would be your answer. Okay, what about equations with more than one log in them? What you need to do when this happens is you need to work it till you get to where there's one log on each side. If you can do that, then you can just drop the logs out and go from there. So what I'm going to do first here, this side, this left-hand side on the first one already just has one log. So I'm happy with that. The right-hand side, though, has 2 logs that are subtracted. This is why we did those laws yesterday. Subtraction means division, so I'm going to write it like this. I'm going to put 10 over the x minus 4. Now, because I just have one log on each side, log base 2, you can cancel those out, which leaves me with this equation, everything except for the logs. Now, because it's a fraction, I'm going to multiply both sides by the denominator, or just cross multiply, same thing. 5x minus 20 equals 10. Move the 20 to the other side, divide by 5. And you get x is 6. Now, one thing you need to do with the logs that I forgot to do in the last slide, you need to check your answer to make sure 6 works. And all you do to do that is make sure no logs become negative. Like if I plug 6 right there, 6 minus 4 is 2. That's all good. So as long as it stays positive, we're good. The second one here already has one log on each side, so I'm going to drop those right out of there. I get x squared plus x equals 20 because the log's gone. And let's go from there. What I'm going to do now is move the 20 over like this, and then try to factor if I can, which I can because I know what factors of 20 would give me positive 1 would be x plus 5 and x minus 4. And I get x equals negative 5 and 4 maybe. Remember, plug it back in. Plug negative 5 in here, that'd be 25 months. That's good. Plug the 4 in. Yeah, they're both good. And you need to do that every time you solve a log equation to make sure your answers are okay. This slide, I went ahead and worked it out in advance because if I didn't, it would take forever. I know you don't like the really long videos, so you're welcome in advance. What if you have one like this right here and you don't have any logs and also you can't find the same base? When you can't find the same base, you actually have to insert a log on each side. Whenever you're looking for an exponent, that's what logs do. They give you the exponent. So instead of writing log, I wrote ln. It doesn't matter which one you use. ln's just got a little bit shorter to write. So I put L in both sides, put the x in the front. To get the x by itself, I put the x in the front, by the way, because it's the exponent. The exponent goes in the front. Divide both sides by natural log 3 right here, and then punch it in the calculator and got 1.77. No big deal right there. When you have an e in the equation, like this second one, you definitely need to use ln because great things happen when you do that. So I did this. I did natural log of both sides. What happens here is since the base is e on the natural log, and you have e to the 2x plus 1, that side is just 2x plus 1. Over here I have natural log 8, so I move the 1 over, divided by 2, punched all that garbage in the calculator, and got x is 0.54. And the last one, this is the worst type in the world. When you have two bases, you can't make them the same, and your exponents are binomials. When that happens, it's just going to take a little bit. So same deal, do natural log both sides, put your exponents in the front. So line 2 right here, really you could skip the first line and just go ahead and, when you write your natural log, just go ahead and put your exponents in the front. Now what you have to do in these is, you got to get there's two x's and you got to get the x on the side by itself somehow. So distribute. I distribute the natural log 3 over here. On this side, I distributed the natural log 2. Gave me all this stuff. Now, I need my x's together, so what I did is I took the 2 I underlined here, and I switched sides. Well, I took this one over there, and I took the 4x over there. Those are the ones that switch sides. Now I have two x's over here. The way I'm going to get that isolate is I'm going to factor the x out of there, which is I did here. That left this over here. So I just divided both sides with that big old thing right there. And then punched it in the calc. And that's a lot of parentheses, believe me, when you punch that in. You can have parentheses around the whole top, parentheses around the 2, around the 3, around the 2, the whole bottom, tons of them. I'll show you a little bit better way tomorrow in class. You have to punch in so many parentheses. It depends on how you want to do it. If you're real comfortable with all the parentheses or not, or whether you want a little bit, what I consider a little bit shorter way. But I'll show you that tomorrow. Couple more cases here. You're going to see something like this that are in quadratic form. Anytime you think quadratic form, it means this. It means your middle exponents have your first exponent. And you can usually solve it, not always, but you can usually solve it by factoring. So what I did is I substituted. I took out my e's and put a z in their place. So then it may look like this, which makes it very easy to factor. So I factored it, got z minus 2 and z plus 1. And that's what I got for my z. But you know what? Nobody cares what you got for your z. You need your x. So z equaled my e to the x. So I took the z back out and put the e to the x back in. E to the x is 2. E to the x is negative 1. Now to get rid of the e, anytime you want to make an e go away, you just put natural log in front of it. So I do natural log of both sides. It canceled here. Natural log of 2 is this. Natural log both sides. You cannot do natural log of a negative number. So the only answer you get on that one is 0.69. And another one of these, we have logs everywhere. So what I did over here, because it was log addition, is you can't add, so I multiplied. So I multiplied and got this right here, x squared plus 3x equals log 28. Now, because I have one log on each side, I can cancel. Do not cancel all 3 logs in the first step when you have 3 logs. Wait until you get one log on each side. Move the 28 over, factor it, and I got 7 and negative 4. Check those up here. 7 is good. Negative 4 is really not good at all. So what you need to do is make sure to mark that out because it cannot be an answer because negative 4 makes that become negative and also that become negative. So you must check your answers for those, those extraneous hint kind. And the last one of the day, I went ahead and worked it out also. I do have 2 logs here, but I have one number that doesn't have a log. So watch this. Not hard at all, but people get confused on this sometimes. What I did first is I took this log over here to join the other one on that side, so it became minus. Remember, if you subtract two logs, you never subtract. That means you divide. So I divided the 3x minus 4 divided by the 2x plus 3. But I only have one log. When all you have is one log, you do the finger thing. The base is 10, so I did 10 to the fourth power. Sorry, first power. I don't know why that looks like a 4 there. 10 to the first power is 10, and that equals this, and the log's gone because I just did the log. So I'm going to cross multiply right here, get 20x plus 30 equals 3x minus 4. Move stuff, move stuff, move stuff. Work it out. I got negative 2 for an answer, but plug negative 2 in right here, and you get a negative number. Plug it in right here, you get a negative number. So because negative 2 did not work, there's no solution. And that's kind of frustrating because you don't know that when you start. You have to kind of go all the way through that work to find out that there's no solution. So hope that's pretty good. Didn't have much issue there. We'll see you in class as usual tomorrow, and we'll get the work done and, have a good time. See you, bye.